Hello, and welcome to the Argyle AI Strategy Summit. My name is Nick with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. To ask questions throughout the session, simply type into the Q&A chat, and we will address your questions at the end of the session. Now, without further delay, I would like to introduce our speaker, Gregory Koidiger, Principal Machine Learning Engineer, CVS Health. We are excited to have Greg with us for a keynote presentation titled AI in Action, Applying AI for Enterprise Advantage. Welcome, Greg. Over to you.
Thank you, Nick. It's a pleasure to be here and welcome everyone. I've had 10 years of machine learning experience working with advanced sequence models like transformers for natural language and beyond. So I'm excited to talk with you today and share with you my experiences about emerging use cases that are powered by the latest advances in natural language and artificial intelligence. But first, I want to start with the traditional enterprise ML approach that I think most people are familiar with here. It starts with exploring the data, you engineer some features, you train a tabular model like a logistic regression or a gradient boosted tree, evaluate that model. If it's good, then you'll deploy it. And then as soon as you deploy it, the model starts to degrade in performance, features naturally drift, and so the process starts all over again. This process, while delivering many successes, is not without its drawbacks. For instance, to develop any additional use case, you typically require your own feature pipeline. That takes a lot of time. And information is lost from transforming text, audio, images, or temporally resolved data into a table for a tabular model. And typically, these kinds of models do not leverage knowledge outside of your enterprise. And not everything is a classification or regression question. So while these approaches have been successful in the past in enterprise, and the remainder of the talk, I'd like to share with you 3 use cases that do not conform to this traditional paradigm that might also be valid. The first use case I'd want to start with is how you can help customers navigate the complexity of your organization using retrieval augmented generation. As anybody would know, that searching for information in an organization is very challenging for customers and for employees. It's open enrollment season, and I know it's very hard for me to figure out what's the best health plan for me, what's covered in any of these plans. And using enterprise search solutions tends to be a very frustrating experience. But modern NLP technologies can help us cut through the cruft and surface the right information for the customer at the right time. LLM search-based retrieval works the following way. First, you take your knowledge base of information. This could be plans that your company offers if you're a software provider. You break that out into chunks. You pass that through a text embedding model. This is the kind of model that takes a variable length sequence of words, free text, and converts it into fixed length vector, where semantically similar text gets converted to numerically similar vector representations. And we then put that into a database, vector database, or just simply into an array. Then when a user comes in with a question, you use the same embedding model to convert their question into a numerical representation and search across your database of documents to retrieve similar documents that can contain the answer to that question. Those similar documents can be combined with the question and fed into a large language model like ChatGPT. And then the model is able to provide an answer to that question using your domain knowledge without having to resort to answering to based on anything within its own knowledge base. Such a system has very significant advantages over using LLMs on their own. For one, it reduces hallucination in the model because the model has access to your proprietary information. The model is much more explainable because you can provide the user that information that the model is using to support its answer, so the user can validate whether the answer is supported by documents within your knowledge base. And the answers are much more relevant to the user's question. However, these systems are not without their drawbacks as well. For instance, if your knowledge base is not complete, a user's query might not retrieve any relevant documents. Moreover, when the knowledge base is being searched, it looks for segments of text that are similar to the question, not necessarily with the answer in it. And when those irrelevant documents are then retrieved, the model might not be able to provide an answer. So when deploying these kinds of models into production, there are several strategies that you can use to improve the ability of these systems to retrieve the right answer. For one, you could improve the prompt through different approaches of prompt engineering. There's been a lot of development in this space, including methods like chain of thought, which ask the model to think step by step to create a plan to answer the question. There are tree of thought approaches, which simulate how a decision tree works within a large language model. You can even interact with the large language model to help you refine the prompt and get its thoughts on what's the right approach for asking your question. There are also approaches in the chunking strategy you can use to break apart your knowledge base. One excellent strategy is to append the section title as well as the document title to a particular chunk. This provides additional relevant context for the embedding model to use to identify relevant context for the retrieval step. You can even use how the system is operating in the live development environment to understand which kind of questions do not surface the right context. And you can use that to guide expansion of your knowledge base to look for gaps in your existing coverage of information. As well as there's an important step to understanding when the model should not be answering the question. There's software out there like guardrails, which constrain the model to answer only questions that are relevant to your domain. For instance, recently in the news, you might have heard about a recipe chatbot that was asked to how to mix a recipe with ammonia and bleach, and suggested a poison. You don't want to be in a situation where your chatbot makes the news. So knowing which questions to answer is very important to deploying a live system. However, RAGs are not the only way that we can better serve our customers. Let's walk through another example, which uses many different capabilities of an LLM to support a very complicated customer service request. Here we'll start with a motivating example. On the left, we have Bill. Bill ordered something from your website, but is not very happy with the product. He tried chatting with a customer service representative through his laptop. He did not get the resolution to his issue that he desired. So next, he called the customer service support hotline. He had to answer all the same kind of questions he already answered in his chat. And he did not find that the experience was very pleasant, still did not get the resolution that he was really looking for. So he posted on social media, venting his frustration about the company. And he decides to call one last time to get an answer to his issue. Now the customer service representative picks up. Are they best equipped to answer Bill's concerns and give him a great customer service experience? Let's talk about how we can use LLMs to enhance this process. For one, we can use an LLM to provide an overall summary of Bill's prior experiences so that the customer service agent is not spending their time asking Bill to repeat information that Bill has already told many times over in previous engagements. We can use the LLM's ability to summarize the chat, to convert the call for using speech-to-text algorithms, and then summarize that, as well as the social media posts that Bill made. We can use those summaries and feed into another summarization step to create an overall picture of what Bill's issues have been. And this, the agent can review ahead of Bill's call to ensure that they are able to spend their time answering Bill's questions instead of having Bill respond to the same exact queries that he's already answered before. Another thing that we'd want to do is understand where Bill is coming from and what kind of personality Bill has so we can better tailor our responses to his personality. We can use an algorithm called speaker diarization, which can split the audio signal from Bill's call into two different segments, one that corresponds to our agent and the other that corresponds to Bill. We can use sentiment analysis over Bill's call to understand whether he's an angry person, is a kind person, what kind of strategies the agent might respond with, as well as understanding what kind of emotional response Bill is likely to. We could also use that on the agent side to understand how is the agent helping Bill and customers like him. Can the agent be coached to use more helpful words and to not respond emotionally when the customer is getting heated? Overall, this can help improve the relevance and the quality of the customer service experience. You can also make great use of the ability of large language models to do zero-shot natural language classification, or at least few-shot classification, where the model is prompted with examples of categories that you might have. For instance, if you're a cable company, you might have a service averaging area. And if you are able to identify what kind of calls correspond to service average requests, you can give a few examples to a large language model, and a large language model will be able to apply those to new examples without having to train a new model. We can take our previous approach of using speech to text to further adjust audio information and process it through the same kind of model, as well as applying that to any social media posts or any other contacts that we make. This provides the agent with a comprehensive summary of the kinds of requests that have previously come down the pipe from Bill and allows them to understand the kinds of requests that Bill will be coming with in a new call and helps them prepare for that interaction. Now armed with all of these different LLM-enabled outputs, the customer service agent is better prepared to be able to handle a tough kind of customer like Bill, and is able to then navigate them from being a detractor to being a supporter of this organization. In my last segment here, I would like to talk about non-natural language use case for transformers. And this is to use them for something would be typically more akin to a recommendation system. Some of the typical issues with recommendation systems are about recommending content to users based on their previous interactions with the content that you might have. So here we have another motivating example. Here we have Mary. Mary likes to browse our website, which serves videos for people. On her phone, Mary likes to browse short form entertainment. Previously, she liked to browse videos about puppies. But more recently, she's gotten interested in kittens. And but on her laptop, Mary likes to use our platform to satisfy her curiosity about her two main hobbies. And that's like guitar, music, and art. Mary logs on to our website on her phone. What's the right content to recommend to her? Now, this is very challenging for traditional recommendation systems, even though for us, I think we would all come to an agreement that probably kittens is the right thing to recommend for me. But this is challenging for recommendation systems because preferences are contextual and they evolve through time. And recommendation systems typically take a very static view of preferences. We have collaborative filtering or matrix factorization approaches that view these content preferences as static and not informed by outside information. And while there are other extensions that can leverage this other additional information of time and context, we can use something akin to a large language model, but this time without language. We can model the entire customer journey as a sequence prediction step. For each step from the login predicts the next step, what content is being viewed, and that predicts the next content that's being viewed all the way down to the end of a session. And that predicts the next session, where the login is likely to come from, what kind of content is likely to be viewed during that next session. The entire customer journey is modeled as a sequence of steps and not as a static kind of preference factor. This allows us to use the same kinds of techniques that we use for modeling language, kind of causal transformer model that powers ChatGPT, but applying it to non-text-based sequences. This allows for preferences to evolve dynamically, as well as preferences to be influenced by where the original login comes from, as well as global time. So the videos go viral, and they might be very popular for a month or two, but then disappear from consciousness. We want to be able to capture these kinds of global trends in popularity. And we can encode dates much the same way that natural language models encode sequence order. And this allows us to step through this prediction and generate next step predictions, as well as fully synthetic customer journeys, and allows us to have a much more nuanced and dynamic view of the customer as they view and use our platform. So kind of ahead of schedule, this is nice because it gives us more time for questions. But with kind of the parting slide, I'd like to recommend some overall tips when you're looking to deploy these models in your own use case. The first one is to start small and experiment. Large language models and the tools that are developed around them kind of blur the lines between builder and user of a tool. If you have a customer service agent and you're developing a tool for them, create a prototype and explore with them what's the right prompt, how is this being helpful, can we refine it. There's an ability for people that don't even know what a tensor is to contribute to advanced machine learning programs using natural language. The other one is that models that face internally, so speak to your employees, are much less risky than models that you deploy out into the wild to anybody. Models that are deployed out to the wild are subject to abuse. People want to perhaps get on the news because they're able to make your model say hate speech. So that's something that we definitely would want to avoid. Models that are deployed to customer-facing operations require red teaming, that is, internal teams that try to get the model to do something it's not supposed to do. That way you can stop the abuse before it happens. As I mentioned, there's tooling out there that can help constrain the model's outputs and make sure that the model is not outputting something that you wouldn't want your company to be associated with. So if you're starting at your first use case, start for building tools for your own employees. That's a lot less risky. And the last piece of advice is that LLMs are great for building the initial experiments. These models are trained with internet scale data. They're highly capable right outside the box. It requires very minimal amount of adjustment for these models to be able to understand what is needed from them. But as you're starting to launch these prototypes, get usage out of them, think about fine-tuning either your own open source model or commercial LLM to more narrowly focus on your use case at hand. This allows them to be better optimized compute-wise and thereby reduce cost. So a much smaller fine-tuned LLM can reproduce the behavior of a much larger open source commercial LLM because it no longer needs to focus on being able to generate poetry or philosophy. It can just simply answer your knowledge-based questions of interest. So that allows the deployment to be a lot cheaper and a lot more controlled. So with that, I'll wrap it up and we'll have time for questions.
Great. All right, Greg, here's a question from the audience. We are struggling to determine our AI budget. Any tips for deciding how far to go in terms of investing in AI and how to gain buy-in from management?
Certainly. Now, I think that this is a great testament to the experimental strategy of AI development. You don't need that much money to develop a prototype. And so you can start small. And if you are able to de-risk the process, show that you're building a valid product, you have no issues in asking for more money once the validity is established. But without establishing that credibility by having a prototype that 70% of the way solves the problem, it's very hard to understand whether you're on the right track, whether more money is necessary. I like to always start small when I'm experimenting because it allows us to kind of not have the pressure of a big budget. And then when I'm comfortable that the risks have been ironed out and that it's simply a matter of engineering, which is guaranteed to work, then that's when I ask for the bigger budgets and the greater organizational buy-in.
Great. Here's another question. What is the number one place where you see AI being a competitive game changer?
I think it's basically going to be everywhere in a little bit. I think what we're going to see is that it's not going to be about the singular kind of AI. It's going to be little AIs in every step of the way. It's going to help the coders code 10 to 15% faster, 20% faster. Customer service agents able to handle 25% more calls. It's going to be in this kind of incremental customer, sort of augmenting your workforce to make them a bit better, but everyone is going to have an AI that's going to be helping them. An AI co-pilot that makes your PowerPoints easier to make, makes your emails easier to write. So I don't think that this sort of singular approach of a singular grand model is going to be the future. It's going to be these multiple incremental approaches.
Great. Here's another one. What's the biggest mistake you've seen IT leaders? Let me take that again. What's the biggest mistake you've seen IT leaders make in trying to implement AI to streamline processes? And how can we avoid it?
Yeah, I think one of the biggest might be to go too far too fast. So, there's an AI ladder where you're augmenting your workforce and then you're trying to make them faster, all the way then to trying to take some of the work that's currently done by humans and automating it fully. So if you don't take that, crawl, walk, run approach, you might be developing a product that is too far and too risky. So you really need to de-risk the entire process as you're developing it to not get into this position where you have 20 workers working on something that's very ambitious, very big, but then you realize, oh, actually, it's not there yet. And now, I have a large team that is sitting around while we're trying to de-risk how we're going to ensure that the model is able to access our code or that our knowledge base is up to date. And so I think that it's really about that gradual scaling up and the de-risking step before committing all the way to building out the product.
Okay. And here's a question. Are some models more user-friendly or intuitive than others?
Yeah, I think that there are models that are easier to use. I think some of the commercial models are definitely easier and more guaranteed to give you the right answers out of the box. Some of the open source models require a little bit more fine tuning, a little bit more experimentation to get right. A lot of even the commercial models, they might be even cheaper to run versus hosting your own because they might be being run at a loss effectively. So I think, it all is very use case specific. So I know internally we have a model comparison like website. We can put in our queries, play around and send them to 3 different models and see where the responses are from these 3 different models. And then we can identify the right model to further invest our time in developing and exploring.
Okay, here's another one. Does training a particular model on proprietary company data really add any value?
I think it's still like kind of up in the air, but it's also just obviously again context specific. So you can go very far with a kind of off the shelf rack system where the embeddings are based on the publicly available model, where the LLM is a publicly available model. And if you have a very standard use case, then you might not need to fine tune your embedding model or the LLM, especially if you do not have a lot of internal data. But if your data is very niche, let's say you're a telecom company and there's a lot of documents around different wireless technologies, or you're a healthcare firm and there's very specific uh, documents around doctor's notes, around healthcare data that's not often available in the public, then you might be in a much better position to fine tune your model on your internal data to squeeze out those last bits of performance to really take a model that's operating good and really get into an excellent environment.
Great. Here's another question. What advances in AI do you see coming online over the next couple of years?
Yeah, I think that's a really great question. For me, I think it's really about orchestrating multiple models. That's going to be where it's going to kind of deliver AI into that next level. So what I mean by that is that a model like an LLM can orchestrate a predictive model, that can orchestrate another LLM, can have many domain-specific models that are able to come up with their answers and then get synthesized into an overall model. You could really imagine this, for instance, in healthcare, where you might have predictive models that are very good at predicting your heart attack risk. You might have models that are good at detecting chest x-rays, as well as blood results. And then you have an overall model that can synthesize that, plus whatever has been recently published in the biomedical literature, and give a doctor or a nurse the right information to make a judgment call as to what's their best treatment option for that member. Again, it's going to be about these kind of fleet of experts, these combining predictive models with generative models into kind of comprehensive model accelerated experiences for our customers.
Great. And I think we can squeeze in one more question. Won't many of the benefits of AI really help out larger organizations?
So it's actually twofold. So yes, larger organizations, they have more data they can use to train their models, but actually it has a huge benefit for smaller organizations that might have very little proprietary data. And this is because basically you're leveraging the compute that's executed across the entire world's knowledge. And so when you're learning over your smaller proprietary corpus, you're actually using that data very kind of efficiently. So you're not using your proprietary customer interactions to learn how to understand English. You're using them only to understand your kind of use case. And so this really allows much smaller teams, much smaller organizations to develop artificial intelligence solutions in the way that they never could have using traditional AI, which really requires large internal proprietary corpuses of knowledge.
Great. And do you have anything to add?
Well, it was a pleasure talking with you all and answering all these questions. Yeah, if anybody has any further questions, they can surely reach out to me over email or LinkedIn.
Great. Well, thank you again, Greg, for such an incredible keynote. And I want to thank everyone else for joining us today. This session, along with all of today's content, will be available on demand following the event.